Okay, I said in fifth hour at least that I would do these two examples, and then actually I will then link it to, or tie it in with the graphing that we did in class as well. All right. So real quickly, well, not too quickly, hopefully. Let me go and now with step A, you don't have to do in either one of these two examples. So this is 1, 2 systems of equations. All right. And so y equals 2x plus minus 1, is already solved for. So you don't have to do step A in either one of these examples. So then what I got to do is go 2, and then in parentheses leave a space, minus x equals negative 4. Okay? And then the 2x minus 1 goes in here, because that is y. It's the same thing. Okay, and then remember the color coordination on the graphs from class. Blue is this guy, red is this one. Okay, so the solution to this is going to be whatever this point is right here. So it'll be a negative, I don't know, something 2/3, I think, if I remember right, and negative something else. Okay, so let's check out, let's try to see if we get this. If that's actually what we get. So I distribute, we get 4x minus 2 minus x equals negative 4. Okay? I'll do 2 steps in one just because I want to go kind of fast. You can pause and try to make sure you know what I did here. Add 2 to both sides and then combine the like terms, combine the x's. And so x equals maybe negative 2/3. Okay? Then, so that's step B and C that I just did, and then step D and E, we replace what I just figured out. So this is half the answer. And actually, if I go back to the picture, voila, I believe that this is negative 2/3 right here. The x coordinate of this point being negative 2/3 seems very plausible to me. That looks about right. So then what we have to do is we got to go back to one of the original equations and really whatever's solved for. In this case, in fact, let me be lazy. Clone and drag it down. What we can then do is we take this negative 2/3 and plug it back in to this blue one. So this is what I called step E. Negative all right, negative 4/3. So remember, when you multiply a whole number times a fraction, it's just you only multiply by the top. So it's 2 times negative 2 gives negative 4. It's kind of 2 over 1. And so remember, when you multiply fractions, you multiply straight across. So 2 times negative 2, negative 4. 1 times 3, 3. And then combining like terms, we get negative 7/3. Okay? So coming back here, this is, let me just erase it and squeeze it in here. Negative 2/3, comma, negative 7/3. And that's that. That's this point right here. And that should seem pretty plausible. Okay? And then let's do the same thing with this other example. So we get, and then just to lead it back to the solving by graphing that we did, that's whatever this point is. So blue and green is the top point, the top vertex. All right? It was really a bad problem in the book because it really is silly to expect you to be able to figure out what fractions these answers are just by looking at them. Definitely not really a reasonable thing to expect, so it's kind of a bad problem. we have 4 times 2x minus 1. That'll put in, I'll try to color coordinate here, y. That's supposed to be a y. Don't judge. So here's the 2x minus 1. Oh, what am I doing? Oh, well, maybe it's good for you to see me make a mistake. That is wrong, wrong, wrong. I'm subbing in for the wrong variable. So I will not edit that out. Oops, oops, oops. Let's fix this. So 4x plus y equals 7. And then we put 2x minus 1 in there as soon as I figure out how to draw 7. Okay. And then, well, that means we have 6x minus 1 equals 7. Oops, not what I meant to do. And divide both sides by 6, you get x equals 8 over 6, which reduces to 4/3. Okay, so x is 4/3. If we go back up here, that's 1 and change, and I believe that that is 1 and change. That seems about right. It's a little bit over 1. So our point that between blue and green is at 4/3, comma, well, we don't know yet. We gotta figure it out. Let me fix this because that looks horrible. Okay, and then we do the same thing. We go back and we plug the 4/3 into this here. Either one of the two equations from the beginning is fine, but if you have one of the variables by itself, might as well use that one. So we have y equals 2x minus 1. And so, of course, x, we know, is 4/3. So we get y equals 8/3, okay, because we do 2 times 4, 1 times 3. Remember, when you multiply fractions, you multiply straight across. So the numerators get multiplied, that makes the 8. Denominators get multiplied, that makes it 3. Minus, and I'll actually show, I got to make a common denominator here if I'm going to subtract them. And so that is 5/3 after all is said and done. And then we go back to this. And then that looks pretty good to me. 5/3 is 1 and 2/3. So 1 and then 2/3. That seems pretty reasonable. And so those are the solutions to the systems of equations. That graphing basically fails because, I mean, heck, who knew? Who would know that that is exactly 5/3? Not me. So you have to go and you have to do it with another method. In this case, substitution method works just fine. So there you go. That's substitution method. A couple more examples, and notice, I mean, you should get the same examples, the same answers, because it's the same problems. So this one on the right we did in class, and then the top one on the left I did just now, and hopefully that was helpful.